welcome again. Turn up the sounds. To the actually ending of the B cell lesson. I'm going to go through this slide here one more time because it's really important, and I want to make sure everyone has sort of all the components. If you want to skip this, you can. But again, I think it's important. This is like sort of like the point of this lesson, and I want to make sure everyone gets it. So I'm going to go through this again. So if we look here, we have the foreign pathogen that has entered the body. And on the cell surface of this foreign antigen are these red triangles, and those red triangles are the antigen. Over here we have a population of B cells, each displaying their own antibody. Okay? And in the beginning, there's not that many B cells that have the green antibody. There's not that many that have the red. So it takes some time for the B cells that have the right antibody to find the pathogen and be able to bind to the antigen. But as you see here, the one that is green, right, is able to bind to the antigen. Okay, and it does. Okay, so here we have the B cell with the right antibody that can recognize the antigen because it's the right shape. Now when that happens, okay, this activates this B cell to begin cloning itself, or dividing, making many copies of itself. And these clones that it makes, okay, are divided into two categories. Memory cells, okay, which do not produce antibodies, okay, but are there in case the infection comes back like months or weeks later. And then plasma cells, okay, so it makes many, many copies of itself, okay. Some serve as memory cells, which are to fight the infection if it comes later, okay. And these are plasma cells. And the job of the plasma cells is to secrete or make large amounts of antibodies. Okay? These antibodies can then float around the blood and capture all the bacteria that are displaying this antigen. And then when they capture the antigen or the pathogen, you know, the antigen is what the antibody is able to recognize. That signals for the macrophages, which we learned about in the beginning of this lesson, to come and engulf and digest the pathogen. Okay? The point is, by cloning or making many more copies of the B cell, there are now many, many, many more antibodies in the blood, which have a greater chance of finding and binding to the pathogen or the antigen on the pathogen, and signaling for the macrophages to come and engulf and digest the pathogen. Okay, now, the next part of this lesson has to do with vaccines and what vaccines are. Okay, and vaccines, okay, in a vaccine is usually a harmless version of the pathogen that has the antigen on it. Okay? So when you get a vaccine, okay, you're getting in your blood the antigen that the immune system can recognize. And what happens when you get a vaccine is that the B cells, right, recognize and bind to this antigen and produce many, 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 many copies of the B cell. Or they make many, many of those memory B cells. In other words, if we go back to this slide here, instead of the actual pathogen being in the vaccine, maybe the only thing in the vaccine is this red triangle. And this process will occur where the B cell in the body recognizes the antigen and produces clones of it. But here's the point. If you get the real infection, if the real infection comes, you'll have many, 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 many more B cells with the right antibody. So therefore you might not get sick, because you already have a lot of B cells ready to fight the real invader if it comes. So this graph down here is really, really, really important. And we need to look at this graph here. It's like probably, this graph has appeared on the AP exam. Okay, so if we take a look here, okay, at day, I don't know, what day is this, 6, is the first, oh, here, I'm sorry. At day 0 is your first exposure to the antigen. Okay, and you'll see it takes about 6 days for there to be any antibodies produced. And you also don't produce that many. Okay, but then, here, 28 days later, you're being exposed to the A antigen again. And if you notice, this time it only takes like 2 days for there to be any antibody production. And you produce much, much more antibodies. Okay, let's summarize this now. This is so, so important. So the first exposure to an antigen is slower and not as much. You don't produce as much antibodies. Okay. The second exposure to an antigen, the response is faster, and you also produce more antibodies. Okay. That allows a stronger response to the antigen, and maybe you won't even get sick. Okay. Now, the question is, what is responsible, okay, for this faster and more amplified response the second time you get exposed to the same antigen? Okay. And the answer for that is that you've already made memory B cells here. Like, being exposed to the antigen the first time allowed you to make memory B cells. So the second time you're exposed to the antigen, you already have a lot of those B cells that are ready, more than before, to fight the infection. Okay? So in terms of like summarizing this, okay, this could be your first exposure to the A antigen could be the vaccine here. Then when you actually get exposed to the real virus or bacteria, the immune response is more rapid and stronger, and then you probably won't even get sick. Okay, now, this could also be in my case, right? My first exposure to the chickenpox was actually getting it. Okay, and I got it full blown, chickenpox everywhere. But now, if I got exposed to the chickenpox virus again, my immune response would be quicker and stronger, and I most likely wouldn't get the chickenpox. Okay. Now, last type of immunity we have to talk about is passive immunity. Okay? And passive immunity is when you get antibodies from another individual. Okay? The most sort of like common type of passive immunity is when the mother passes antibodies to the baby in either the placenta, when it's in an embryo, or in the mother's milk. Okay, and this is why breastfeeding is considered to be really healthy for infants, is that it gives the baby antibodies to protect the baby against pathogens before its immune system is developed. Okay, you can also get passive immunity by injecting antibodies directly into the blood. But again, this immunity is only short term, because eventually those antibodies will go away. You're not injecting the B cells, you're injecting the antibodies. So eventually these antibodies will be degraded, and the immunity is only short term. But again, this is passive immunity because your body is not making the antibodies. Okay, you're giving the body the antibodies. All right. Well, that is the end of the video. Go answer the guided questions, and I'll see you all tomorrow. Hopefully tomorrow you're a little bit more focused. Today the focus wasn't that good. All right. Have a good evening.